Let me start with the simplest technique for finding the interpolant for n plus 1 points. First of all, let me review the definition of the interpolating polynomial. We saw that for a set of n plus 1 nodal points, such x0, y0 and x1, y1. Okay, there is a unique polynomial p belong to Pn. It means that p is a polynomial of degree at most n. So if, for example, we have 3 nodal points, p should be a polynomial of degree 2. Okay, such that pxi equal to yi. This is the, in fact, definition of interpolation. Now, let me show you the simplest method for finding the interpolating polynomial. Let me start with okay. Unknown coefficient method. What's the unknown coefficient method? Let me show you by an example. It's very easy technique that you can apply it for a table of nodal points. Suppose that we have something like this: x0, x and y. Okay, xi and yi. Let me consider, for example, 2, 1, 1, for example, 3, and minus 1, for example, 2. 3 points is enough. So, by the definition of the interpolating polynomial, we know that there exists a p2 belong to p2 such that p2 of xi equal to yi. Okay, so let me consider that p2 as a polynomial of degree 2. Let me call it a2x squared plus a1x plus a0. We should have these equations for I equal to 1, 2, let me 0, 1 and 2. So this will be p2 of x0 should be y0, p2 of x1 should be y1, and p2 x2 is y2. Okay, and this gives p2 of x0. You put instead of x0 2 in this equation, so we will get 4a2 plus 2a1 plus a0 should be equal to y0. It means 1. Okay, and for the other one, x1 is 1, so it will be a2 plus a1 plus a0 equal to 3. And finally, we put minus 1 here. It should be a2 minus a1 plus a0 equal to 2. Here we will have a system of equations, a system of 3 equations with 3 unknowns. We can solve this equation if the determinant of the coefficient will not be 0. This system has a unique solution. Okay, We can find the solution for this equation. Let me compute the solution and write it for you. If we solve this equation, we will get a2 equal to minus 8 point minus 0 minus 0.833, a1 equal to half, and a0 equal to 3.333. Okay, so the polynomial will be p2 equal to minus 0.8333x squared plus half x plus 3.333. This is the polynomial. But there is a very big drawback here, and you can see this drawback when the number of the nodal point increase. For example, let we put a 3 and, for example, minus 1 here, 8, 7 here, 5, 4 here, and so on. Here we will have 1, 2, 3, 4, 5, 6 nodal point. So the polynomial will be of degree 5. And here we will get a system of 5 equations with 5 unknowns. And actually we know that when the number of unknown and equation increase, it is very, very difficult to solve a linear system with non-iterative and direct methods. So in fact, in any area of the mathematics, we don't use this method to finding interpolating polynomial, because, for example, if you have 100 nodal points or 101 nodal points, you will have a system of 100 equations with 100 unknowns, and in fact maybe it's impossible to solve. So we cannot use this method at all, and we have to find a good replacement. Okay, so from now we forget about this method and we start a new method that we call it the Lagrange interpolation. Okay, Lagrange interpolation. Let me finish this course here, this lecture here, and I continue to Lagrange interpolation in the next lecture, because it needs in fact about half an hour, and I would prefer to split my lectures. So please subscribe my channel and introduce my channel to your friends. Thank you.